And so today we are considering vertical motion. Right? This is motion of an object thrown upward or motion of falling objects. And it's known as motion under gravity as well. Now let's look at equations of vertical motion now. We have V is equal to U plus or minus GT. And then H is equal to UT plus or minus half GT squared. And then H is equal to U plus V over 2 close bracket T. Understand that we are using Y in this equation to show that it is vertical. Just like when we did horizontal motion, we use X, UX or VX. So here we are using UY or VY. It's important to also know that the last equation says V squared is equal to U squared plus or minus GT. Please understand that we use minus when the object is moving upward. So this equation will become U minus GT. And the second one will become UT minus half GT squared. UY plus VY, minus VY over 2 times T. Or V square Y is equal to UY minus 2G. So you are sticking with minus when the object is moving upward. You stick with minus. If the object is falling downward, we use positive. So if the object is coming down, we can say that the first equation will become V is equal to U plus GT, or H is equal to UT plus half GT squared, or that H is equal to U plus V over 2 multiplied by T, or that V is equal to U, V squared is equal to U squared plus 2GH. So understand that the minus is used when the object is moving upward, and then if it's falling downward, we use positive. So that's that about that. Now, we want to look at theories of vertical motion. There are certain theories we need to understand about vertical motion. It gives us a comprehensive knowledge of vertical motion because vertical motion is just controlled by gravity. So there are predictable things about vertical motion. And first and foremost, if the object is projected upward or is moving upward, now what can we know? First of all, an object cannot move upward except you force it, except you give it an initial velocity. And that's what the first one is saying. For an object to move upward, it must be projected with a particular initial velocity. I must throw this object upward, this marker upward, for it to go upward. That's what I'm trying to say. So the first one is just simply telling us that an object cannot move upward on its own without you throwing it upward. Now the next one says that as the object moves upward, its velocity decreases. You need to understand that as this marker lifts my hand, I throw it upward and it lifts my hand. As it's going up, the velocity will be reducing. So as it's going upward, let me assume it lifts my hand with the velocity of 30 meters per second. As it's moving upward, the velocity will be reducing from 30 to maybe 25, 25 to 20, 20 to 15, 15 to 10, 10 to 5, 5, then to 0. Until it gets to 0, it will keep moving upward. So as the object keeps going upward, if it still has velocity, it should keep going upward until that velocity turns to 0. That's what he's saying, that as the object moves upward, its velocity decreases until it becomes 0. That's what the second one is saying. Then at 0 velocity, obviously at 0 velocity, the object cannot go up again. Hence, it has attained its maximum height. So we can say at 0 velocity, the object attains its maximum height. That is, at maximum height, the final velocity is 0. So the velocity with which it used to leave my hand is the initial velocity. And the velocity it adds when the object has attained its maximum height becomes the final velocity, if I'm considering from when I throw it to when it attains the maximum height. So that's that about when the object is thrown upward. What about when it is falling? For an object to fall under the influence of gravity, understand that the initial velocity must be 0. Let me illustrate this now. Look at this marker now. It's not moving. The velocity is 0. It's not moving. If I release this marker, I just remove my hand from this marker. Obviously, this marker will fall. So for an object to fall, its initial velocity must be 0. Don't confuse the initial velocity used to throw it with the velocity it used to fall. In motion, especially vertical motion, I like separating these two types of motion. I solve for upward motion separately, and I solve for downward motion separately. So for the downward now, if the object will fall, we assume the initial velocity to be 0. except you force it. But again, we are not considering when you just force it downward. We are considering when you throw it under the influence of gravity. So it's just released under the influence of gravity. Only gravity is acting on it. Then initial velocity must be 0. Again, as the object falls, its velocity does what? It increases. So as it's going down, the velocity will be increased. From 0, you see 10, 20, 30, on and on as it falls downward. Again, the final velocity is recorded when the object just touches a platform or when it touches the ground. In this case, if I release this thing until it touches the ground, then that's when I record the final velocity, when it's about touching the ground or when it just touches the ground. The velocity with which it touch the ground, that's the final velocity. Secondly, I want us to understand that the time it takes an object to move from a platform to the maximum height, it's the same time you take the object from that maximum height to come back to that platform. If it takes 3 seconds to move from the platform to the maximum height, it also takes 3 seconds to move from the maximum height to the platform. Well, all of this can be summarized here now. We can summarize it here. Look at it now with this simple diagram. Now, if it's a platform, this is the motion of an object shown vertically upward. First of all, it goes up with a particular initial velocity, which we don't know. Then let's assume this is the maximum height. You get to this point, the velocity becomes 0. This is the maximum height, h max. So as it's going upward, velocity decreases. Velocity decreases. The velocity decreases. So as I throw this object with a particular velocity, maybe 40, as it's going upward, it will change from 40 to 30, 30 to 20, 20 to 10, 10 until it becomes 0. That's that about that. Now, when it's going to fall, again, we have another initial velocity. That u must be 0. Well, let's call this uy, and let's call this uy, and let's call this vy. Now, as it's coming down, velocity will be increasing. So velocity increases as it comes downward now. Increases. So this one is going upward, and this one is coming downward. The final velocity is recorded when it's about to touch the ground or when it just touches the ground. So all of these theories can be summarized in this simple diagram. Going upward, velocity decreases. Coming downward, velocity increases. The last thing I want to say is that for this motion we want to study, we assume our g to be equal to 10 meters per second squared. So for each question, you don't need to be giving your g. Just remember that your g is 10 meters per second squared. So we're taking some examples now. Example 1 now. A stone is thrown upward from the top of a table with an initial velocity of 40 meters per second. So solution, we are given that the initial velocity when it was thrown upward was 40 meters per second. Calculate A, the velocity after 3 seconds. So for the A part of this question, I'm asked to find the velocity at time 3 seconds. Understand, like I said, you don't need to be giving the value of your g. We assume g to be 10 in this case now. The value of g is not an issue. Some say 9.82 and some I love using a rounded figure. Well, 10. So that's that about that now. How do we get the velocity? We are given v, we are given t, we have our g, and then we have u. Obviously, we are asked to get v, sorry. So obviously, the first equation here is what we're going to use. So we have vy is equal to uy minus gt. Now, we're looking for vy. Why is it minus? Or understand, the object is thrown upward. So it's going upward initially. And so, that's why we're using minus. Vy is equal to, what's the uy? 40 minus 10 times 3. Because time is 3. Gt. This will give us 40 minus 30. And that's 10 meters per second. Now, I want to ask one question. Looking at this question, the object was first thrown upward with a velocity of 40 meters per second. As it's going upward, the velocity kept on reducing until it becomes 10. The question I want to ask, first of all, do you think this object will, after these 3 seconds, will it still move upward or it won't? What will be your answer? I would like you to drop your comments on the comments, your answer in the comment section. Well, it would move upward. Now, second question I want to ask also is, Do you think from the tabletop to the maximum height, what time do you think this object will take? Will it take less than 3 seconds? Or more than 3 seconds? Or just 3 seconds? Well, let me answer that. It will take more than 3 seconds. Why? If it takes 3 seconds for the velocity to reduce from 40 to 10, obviously for the velocity to reduce from 40 to move up from 40 to 0, it should take more than 4 seconds. Because that 0 is when it attains the maximum height. So, but that's by the way, actually, it's not part of the question. Let's solve the B part of this question. We have to get the maximum height. Whenever you hear maximum height, understand that your Vy at that point is 0. And you have your G. So what is required here is the H, maximum height. So we say Vy squared, this is what we use, is equal to Uy squared minus 2GH. I'm using this formula because we are looking for, we have V, we have U, and we have G, we are looking for H. So that's what is best to use. I cannot use a formula that has T, this has T, this has T, this has T, because we don't have the time it takes to the maximum height. And I cannot use this 3 seconds. And the reason is because at 3 seconds, the velocity is still 10, meaning that it will still take more than 3 seconds to get to the maximum height. And so my V 0 squared is equal to U, which is 40, we're giving that here, 40 squared, minus 2 times G is 10, then times H. This will give us 0 is equal to 40 squared will give me 1600 minus 20H. You can bring this here. 20H is equal to 1600. And dividing both sides by 20 now. Our H is 80 meters. So that's the maximum height it attains. Where this B has a second part, we are asked to get the time taken to reach the maximum height. Well, with this, if you're looking for time, we have V, we have G, we have the U as well. And we're looking for time taken to get the maximum height. Well, we can use this. That Vy is equal to Uy minus GT. Now, why is it minus? Because the object is going upward. In fact, anytime you are solving for maximum height, have it in mind that the object actually is going upward. And so Vy, because an object going upward is what attains against height. An object coming down cannot be attaining height. It's reducing in height. So Vy is equal to 0 and Uy is 40 minus 10t. We can bring this 10t here. 10t is equal to 40. From here now, we can divide both sides by 10. So 10t over 10 is equal to 40 over 10. And then we can get that our time is equal to 4 meters per second. And that's that about that. And lastly, we are asked to solve the C, time taken to return to the tabletop. Time taken to return to the tabletop. I don't want to clean this part because it contains our formulas. Time taken to return to the tabletop. Well, I want to say this now. There are two methods. I will just take the first method first. We understand that if it took 4 seconds from the tabletop to the maximum height, it also takes 4 seconds from the maximum height to the tabletop. So time taken to return to the ground means the entire time it took. That time can be gotten as 4 plus 4. And that's 8 seconds. Time taken to return to the tabletop. Now, again, there's a method 2. You can solve separately now. We know that the time taken to get to maximum height was 4 seconds. We've solved for that. What was time taken to return back? We can solve for that. That's method 2. So I want to solve the time it takes from the maximum height to the ground. From the maximum height to the ground. Obviously, if it's going to fall, if this is the tabletop now, and it's at the maximum height somewhere here, it has gone to the maximum height, I know it wants to fall from here to here. You only want to fall from here to here. What's the vertical distance with the cover? Obviously, it's covering a vertical distance of 80 meters. Why is it covering a vertical distance of 80 meters? Because it gains 80 meters. So when it's coming down, it will also lose that same 80. So the vertical distance to cover is the same 80 meters back to the tabletop. So at that point in time, I can say my H is 80 meters. And again, what was my u? Our uy is 0. Remember, for an object to fall, its initial velocity must be 0. And then our g is 10. With this, we can get our answer. And that will give us that h is equal to uyt plus half gt squared. Now, I'm using plus because the object is falling now. Time taken to fall from the maximum height to the ground. So h is 80. My u is 0 times time, which is what I'm looking for, plus half times g10 times t squared. And t is what we are looking for. So at the end of the day, we can say that 80 is equal to 0, yeah, 2 here 1, 2 here 5, plus 5t squared. So dividing both sides by 5 now, because this 0 can go off, divided by 5 and divided by 5, we have that 16 is equal to t squared. At this point in time, we can take square roots of both sides. Take square root of this, take square root of this. We get that t is equal to 4 seconds. And now what I'm trying to say, that it took 4 seconds to go to the maximum height, it takes 4 seconds to come down. And then total time taken to return to the ground becomes 4 plus 4 again. And that's 8 seconds. Actually, there's a third method to this, and I would like to talk about it because this question is like a kind of a brief summary of every other question I would want to solve. And so let's take the method 3. Now, I'm going to clean this part. Now, pay attention. Now, take note now that if this is the tabletop, and an object is shown upward and gains a height, when it comes back, it loses that height to the tabletop. So, eventually, you can assume that h is equal to 0 when the object has returned back to the tabletop. And you can use that information to solve for the time taken, the whole time, entire time taken for the motion. So we can now say, therefore, our uy is 40. The initial time it was used to, it was thrown that u was 40. Then when it returns back, the h, the height, will have become 0. It gains 80 and lose that 80 at the end of the day and becomes 0. And then you can use your g as 10. If you do this as h is equal to ut minus half gt squared, where t is the time taken. Where t is the time taken for the entire motion. Your h is 0, meaning that you are saying it has gone up and returned back to this tabletop. Is equal to your uy is 40 times that t minus half gt squared half times g10 times t squared. So this time I want to get now, it's time taken to start from here, go up and then come back again. You can therefore see that from this, if I bring this here, 2 here 1, first of all, 2 here is 5. We have that 40t minus 5t squared. With this now, we can therefore get that if we bring this one here, 5t squared is equal to 40t. Dividing both sides by t, or 5t. 5 cancel 5 and t cancel out this will give us t is equal to t cancel t and 5 here will give us 8 seconds eventually. And that's the entire time. Now I'm trying to say, which correspond with every other thing we've solved. So that's that for this question. Example 2. A mango fruit dropped from the top of a tree 45 meters tall. How long will it take to reach the ground? Well, this object is going to fall. And since it's going to fall, it's an example of a vertical motion actually. My u must be 0. Again, our gravity is 10 meters per second squared. Now understand that it will cover a vertical distance of 80 meters. So h is 80 meters from the fruit to the ground, 80 meters. So we want to calculate time it will take to reach the ground. Obviously, this will be h is equal to uy t plus half gt squared. So this will be h 80 is equal to u is 0 times t plus half times g 10 times t squared. So this will be 80 is equal to, this will go because 0 times t. Remaining 2 here 1, 2 here 5. 5t squared. Dividing here by 5 and dividing here by 5. We get that t squared is equal to 16. Taking square root of both sides, our t will be equal to 4 seconds. So that's that for this question. Example 3. An object falls freely from a height of 25 meters. Let me assume it falls here, and this is the ground, and the vertical distance from here to here is 25 meters. It falls here to the top of a roof. It is the roof of a building, and then the height of this building is 5 meters. So you need to understand that it must have covered the vertical distance of 20 meters, which is 25 minus 5. So this is the vertical. It falls from here down to the roof of this table. So this must have been 20, which is the height it covered would have been 25 minus 5. The vertical distance is covered. That's 20 meters. Again, our G is constant, 10 meters per second square. Now we're asked to calculate the velocity with which is used to strike the roof. Well, we're looking for V, Vy. Again, understand that our Uy is 0. So we can now say H is equal to Uyt plus half. So we can't use this because it contains no V. So we're going to use Vy square is equal to Uy square minus 2gh. The V is what we're looking for. Our U is 0, 0 square minus 2 times our G, 10, times the vertical distance is covered, which is 20. So we can say Vy square is equal to 2 times 10. So this ought to be plus because it's falling downward. So 2 times 10 times 20. That will give us 400. So we take square root of both sides. Take square root of this side. Take square root of this side. We eventually get that Vy is equal to 20 meters per second. That's the velocity with which it strikes the top of the roof. Example 4. An object is thrown upward with a speed of 20 meters per second. That's the initial velocity. Calculate the maximum height reached. Once you say calculate the maximum height, I know that Vy is 0. Then I have my G, 10 meters per second square. And so what equation should I use here? I'm going to use the fourth one. But that's what will suit this question. Vy square is equal to Uy square minus 2gh. Why minus? Obviously it's going upward. So V is 0 square is equal to 20 square minus 2 times 10 times h. So this will give us 400 minus 2 times 10, 20 times h, 20h. Making this here will give us 20h is equal to 400. Dividing here by 20, dividing here by 20. What's our h? 20 meters. So that's that for this question. A stone is thrown upward, that's example 5, and returns to the ground. Which of the following figures represent the velocity time graph? Okay? Now, this is a very simple question. Remember that when you throw an object up, the velocity reduces till you get to the maximum height. At that point in time, the velocity is 0. I want to illustrate this. Imagine an object was thrown upward with a velocity of 40 meters per second. So, this is the velocity when it's thrown upward. And this is the time. At V is equal to 40 meters per second, the time will be 0. That's the first velocity it has when you throw it upward. As the velocity reduces to 30, you may say that happens in the first seconds. In the second second, the velocity reduces to 20. And in the next second, the velocity reduces to 10. That's 30 seconds. At the fourth second, the velocity reduces to 0. Now, this is the motion when the object is moving upward. What of when it's coming downward? What would happen? Velocity and time. Well, quite simple now. As it's coming downward now, the velocity will be increasing. So at initial time, the velocity was 0. That's initial velocity. Then it should not be dropping down. The velocity will be increasing. In 1 second, the velocity has increased to 10. In the second second, it has increased to 20. The third second has increased to 30, and in the fourth second it has increased to what? 40. This is what it looks like. Now, if I want to plot a graph of this, how would it look like? Well, quite easy now. Your maximum velocity is 40, and minimum is 0. So, at 40 meters per second, what was the time? I mean, when it's going upward, the time was 0. That will be somewhere here. This is my 1, 2, 3, 4, 5, 6, 7, 8, the time, on and on. Now, at 40, time is 0. This will be this. At 30, what will be the time? 1. Somewhere here, this is 40, 30, 20, 10, and 0. So, it is here. Now, at 20, what's the time? 2. This is somewhere here. At 10, what's the time? 3 seconds. This is somewhere here. At 0, this is somewhere here. If you draw this, how will it go? That should give you a picture of what our answer should be. That should be C. And if you keep going on and on again, you will realize that at the 5th seconds, now, because at 40, velocity is 0, that is standing for this. At the next seconds, which should be the 5th seconds now, the velocity becomes 10. This should be the 6 seconds because I'm adding to this time here. This should be the 6 seconds. So at the 6 seconds, what should be the time? The velocity 20. And then if you continue on and on, you realize to go like this. So that's why this is the graph for that. It's got the velocity time graph for this. That's about that. This is a common question in JAM. We can take these exercises and the answers are there solved and then confirm with the answers that are written here. So that's that for this.